everyone, welcome to our online open course. We will learn the program designing for flat and straight-walled products. There are 5 machining tasks for this product in total, which means there are 5 processes. Before class, you have independently studied CAM program design, and you should already be familiar with the software interface. Now let's begin with the first process of this product. For each process, we must follow these steps. Create tools. Establish the workpiece coordinate system. Create the blank. Develop the program. Simulate the machining. Optimize the program. To facilitate learning, we will create programming templates for the first process of each product in the future. You only need to complete the 3 processes: program development, machining simulation, and program optimization. The specific steps are as follows. First, enter the UG machining interface and open the part machining option. Second, select suitable tools based on the technical requirements of the product and create various tools. The tool file name can be set as D30RO, where D30 indicates the tool diameters of 30 mm and R indicates the tool corner radius of 0 mm. Third, create the machining coordinate system. Measure the basic dimensions of the part, then enter the geometric creation interface and create the MCS coordinate system. The coordinate system must be set on the upper surface of the workpiece and the name can be arbitrarily set. Fourth, create the process. This process uses the method of flat milling. The details include specifying the boundary, setting the tool path, and simulating and analyzing machining. For detailed operational specifics, please refer to the skill operations. Let's start the rough machining process for the internal groove of a flat-walled product. First, in the modeling module, we measure the distance between 2 surfaces, setting it to 18 mm, and click on DC to move downwards. Click Menu, find Edit to move objects, and set the downward movement to 18 mm. Select the object to be moved and click OK. Next, we will enter the Application module and select the Machining module. Click on Planar Milling. Click OK in the Machine Tool view. First, create a cutting tool. Start with an end mill. Input D30RO. Then click OK. Change the diameter to 30 mm and click OK. Then create a second tool for fine machining named D10RO and click OK. Change its diameter to 10 mm and click OK. After tool creation, proceed to the Geometry view and create a geometry. Start with MCS. Renaming it to A and clicking OK. Then create a geometry. Create the workpiece, naming it AA, and click OK. Specify the workpiece pick the part to be machined and click OK. For the blank, choose Bounding Block and move it up by 1 mm, then click OK twice. Next, enter the program. Create a new program and choose Planar Milling. Select the 30 mm tool and the AA geometry. Choose Rough Machining. Name the operation Internal Groove Rough Machining. And click OK. Pick the boundary and the face boundary. For the tool side selection, let's check if the tool side is on the inside or outside for machining. If it's on the inside, set it to internal, then click OK, and select the bottom surface. Pick the surface to be machined, and click OK. Then enable layered machining and set the step over to 1 mm. Cutting 1 mm per pass. Adjust the cutting parameters, changing the feed rate to 30 mm per second, spindle speed to 800 RPM, and feed speed to 200 mm per minute. Then click Calculate, then click OK. Generate the tool path and confirm it. Right-click on the mouse and select Tool Path. Then click OK and click Play. WCS axes are color-coded, with the X-axis represented by red, the Y-axis green, and the Z-axis blue. When programming CNC, consider setting the workpiece coordinate system, especially when machining flat surfaces, using planar milling operations. After the simulation, click OK. Then right-click to access post-processing menu. Find the corresponding post-processing file. Choose either metric or imperial units. Then click twice OK to override the file and generate the program, which can be modified and optimized based on the specific equipment used. Remember, when choosing the part boundary for planar milling, the term internal refers to the machining area that tool selection depends on the structure and material of the workpiece and the precision required. The operation process is now complete. The details of flat milling are linear processing, which involves checking the machining geometry, analyzing and measuring the machining geometry, principles of establishing coordinate systems, selecting the machining range, setting the boundary geometry, choosing and cutting mode, setting cutting layers, setting cutting parameters, setting non-cutting movement parameters, setting feed rates and speed parameters. Based on the above operational details, you can practice on your own according to the operation demonstration. The first process of the product may seem intricate and important, but once you understand the process, the operation becomes quick. In this process, don't forget to set a 0.5 mm allowance. The difficulty of this process lies in choosing non-cutting parameters. Thank you for listening.